Good afternoon, and I welcome you, students. The very important topic on the screen: periodic classification of elements. What are elements? First of all, if I say what are elements, let us understand what do you mean by periodic classification of elements. You know, you are saying carbon is an element, hydrogen is an element, nitrogen is an element, oxygen. So many elements we know, and by now 118 elements are known. How many? 118 elements. And you know, some elements are very common. What do we mean by element? The matter which we have around us. You are drinking water, for example, you are drinking water, you are inhaling air. Air contains, you are saying, oxygen gas is there, nitrogen gas is there, and few more gases may be there. In water, you are saying it is a compound, and we know the formula you are representing like H2O. Then you are saying there is a carbon dioxide gas in the atmosphere. You are saying ammonia is a gas. All these compounds you are aware of. You have read in chemistry different type of compounds. You are saying CaCO3. You read limestone. What I am trying to tell, that the substances around us, the substances, the matter around us is made up of what? This matter is made up of what? This is made up of, there are elements. You are saying there are compounds, there are mixtures. You have a juice, it is a mixture. How many things are there in that? If you know the composition of that. So matter is made up of, we are saying, elements, compounds, and mixture. And element means the substance. Element itself is a substance, posing it cannot be broken by chemical means. By chemical means. Can we break carbon by chemical means? Can we break hydrogen by chemicals? In nitrogen, oxygen? The answer is no. And what is these elements? Each element is made up of an atom. Each element is made up of what? Each element is an atom. And different elements are different atoms. We are saying different elements are made up of different atoms. Different atoms. And atoms, you have been told what is atom. Atom is characterized by protons, neutrons. The subatomic particles inside the atoms are proton, neutrons, and electrons. And there is an atomic number which we defined. Every element has an atomic number. That means the number of protons, which is characterized by number of protons. If I say carbon, you represented carbon by 6C12, for example. That means there are 6. Atomic number is 6. Atomic number is 6. The number of protons is how many? 6 protons. It has protons, 6 protons. So hydrogen has 1 proton, atomic number 1. Nitrogen has 7 protons, 7 atomic number. Oxygen 8, like this. The elements, how many elements are there? Now these elements have different atoms. They have different number of protons, and they combine to form large number of substances around us. These, even carbon, you know, it forms millions of compounds. Millions of compounds. And then hydrogen forms. Now, as I said, there are 118 elements. Attempts were made to study. Can we study the properties of 118 elements separately? Then there was a problem, because these elements have got properties, physical and chemical properties. As done in the, as you will see the history here, that earlier there were very less elements which were known. 30 elements, 40 elements, like this. They were discovering more and more elements, more and more substances were discovered, more elements were discovered. The problem was that what can we form some classes of the elements which have similar properties? Every time we are talking of classification means what? Why do we form classes in anything, whether physics, chemistry, or anywhere? Why do we form classes? You are a student of 12th class. You are a student of 10th class, then you know you have similar subjects. Like science, you have In science, you have physics, you have bio, you have chemistry, you have English. So that class, 10th class is different from 9th class. So we have formed classes. After you pass a 9, you go to 10th. Then when you will go to 12, there will be different classes: science section, commerce section, art section. So classification is always based on certain characteristics, certain properties. The scientists were interested that instead of studying individual elements and studying their properties of the compounds, substances they will form, we want to classify the elements in certain groups which have similar type of properties, so that it becomes easier for us. If I place certain elements in a group, for example, if I place, say, carbon, silicon, germanium, tin, lead, they are saying this is now in group 14. That means there are some similar properties which they have, and then the study will become easy. So classification of element was a challenge, because otherwise, as more and more elements were being discovered, there was a chaos. Each element has its own characteristic, each element has its own properties, each element is forming compounds, substances. So can I tell that which carbon can form what type of compounds, what type of oxides, what type of hydrides, or what type of chlorides, and what will be the properties of those compounds? So, but if we can form certain groups, of the elements, then we will be able to find out that what type of compounds they are being forming, what type of physical properties in general they have. Whether, if I say some substances are metals, then you say some substances are non-metals. Now you already know there are some substances which have properties between metals and non-metals. So that could be mean we are trying to classify the elements on the basis of properties, on the basis of characteristics, because the number is growing, and as the number is growing, the information is large compounds found by different elements. Therefore it will become important, and if we can classify the elements on the basis of some characteristics, some properties, so that we can study the whole groups, whole class, rather than individual elements. That is the idea. So if I teach every student separately, tell me in a school, it will not be possible. So they have formed groups, they have formed classes, 8th class, 9th class, 10th class, in 12A, 12B, 12C. So when we have classes, then it is easier, because then it becomes possible to teach the classes of 60 students, because they have the same characteristics, same subjects, they have same physics, same bio, same chemistry, same English, and then we can also test them accordingly. Therefore, I hope it is very clear that as the scientists were discovering more and more elements, and they were finding more and more new substances, it became necessary that there should be some classification of the elements. And we will study in this some history of the classification and some important events, some important scientists which started making these classes or groups of the elements. Well, first of all, now we understand what are elements. Now I said 118 elements are there. Each element cannot be broken simply by chemical methods, by simple chemical methods, and each element has an atom which is different from the atom of the other element, because it has different number of protons. Hydrogen has different number of protons, nitrogen has different, oxygen has different, uranium has different number of protons. So their atomic numbers are different. They are different elements. Their atoms are different in mass, in number of protons, and some other things also. Therefore, the classification means we want to classify and form groups of the elements which have similar characteristics, similar properties. Periodic, when I say your word periodic, periodic means something which repeats. Periodic classification means there will be a table, there will be, can we put the elements in a tabular form which repeats after a regular interval? That is periodic. Something which is periodic, something which repeats. Let us see how it is done. As I said, students, at present 118 elements are listed, are known to us. All these elements have different properties. 118 elements mean 118 elements have different properties. What properties we talk in science, in chemistry, what we talk physical properties. We are talking of physical, chemical properties. What is the color? What is the density? What is the mass? And these elements, whether they exist in solid form, they exist in liquid form, they exist in gas form. Oxygen is in the gas form, in the atmosphere. Carbon, solids of carbon. Carbon is existing in the form of coal, coke, or you are seeing solids. Then certain liquids, elements could be there in the liquid form. All this bromine is liquid. So different physical states are there for solids, liquids, or for substances, what we know. And out of 180, only 94 are naturally occurring. Now, this is the important point here, naturally occurring. In the nature, what we found, 94 elements. If they are stable, student, they will exist. If something is not stable, it reacts. What happens? It reacts. Or if it is not stable, it has a short life. It has a short life. It will transform into something else. It will change. It is not stable. It will break into some other species, into smaller things. And then that means out of 118, only 95 and the rest elements have been discovered by man. And where they are discovered, they are man-made or artificial, what we say in nuclear reactors, nuclear reactions. There are a lot of nuclear reactions. Student, nuclear reactions take place. They are not stable. They will undergo certain reactions. Or in nuclear reactors, they have been made. Okay, they are not very stable. That means. So this is the first thing. Second, why do we need to classify elements? Already I said the number of elements becomes very large and they form very, very large number of compounds. It will not be possible to study each element separately and their properties, their compounds, substances. But if we group them in some classes, then it will become easier for us to study, because in a group they have similar properties. We put them in a group. The number of elements discovered has increased, making it difficult to remember the behavior and properties of these elements. Hence, it is important to classify elements according to their properties. It is necessary to understand how they form compounds. So if I can form classes, then it becomes easier. Even, in bio, you have seen there are classes of bacteria, there are classes of viruses. What we are trying, so in a particular class of organism, spread certain type of diseases, and we have created, scientists have created certain medicine, drugs, vaccines for a particular class of pathogens or organisms. So classification is always important. It is required when we want to study something. Otherwise, the information will become chaotic and it will not be systematic. So if we want to make study systematic, we must form classes. So grouping of elements into different classes is called periodic classification of elements, and these classes will have definite, or there should be similarities or characteristics, what we say characteristics or properties. Their properties should be similar, physical properties or chemical properties, and what type of compounds they will form, they must be quite similar. Therefore, we can say we will be able to classify these elements. And that was an attempt now how to classify the elements. Let us see which scientists have been working on this. And that's what NCERT books talks about. What I said, making order out of chaos. As I said, the number of elements increased, number of compounds increased. Therefore, this is chaos. Which elements have which type of characteristics? It will not be possible to study separately. Therefore, it is required that we should form classification of the elements. So what were the earlier attempts which were made to classify? Why do we classify the element? The method of grouping elements into different classes is called periodic classification. It helps us to understand the properties of elements and their compounds. when I will be able to classify or form groups, then it will help, we will be able to understand the properties. It will help us to understand the properties of elements and their compounds. How many compounds? There are very large number of compounds. Very large compounds are formed. Each element is forming very large number of compounds. And if I put certain elements in a group, that means they will form similar type of compounds. And therefore, it will become easier for us to study the properties of these compounds. These properties, otherwise, can I study the properties of each and every compound individually? There will be, this all information is very vast and very big. Second, based on their position in periodic table, one can predict the property. And I will, once I classify and put them in a table, tabular form, supposing we put the elements. What do you mean by periodic classification? In certain periodic table form. So this can give us information already and predict the behavior and properties of elements and their compounds. If I say in the periodic table, I say there is a group supposing 1, and in the group I said there are alkali metals. So this helps me in predicting that lithium, sodium, potassium, rubidium, if they are in group 1, they are metals. They have similar type of properties. And they are forming similar type of compounds, like when they react with oxygen, they react with hydrogen, what type of compounds they will form, similar. So this will help us. If I say that if I put a group of halogens, supposing halogens, if I say halogens contain chlorine, fluorine, chlorine, bromine, iodine, then we know what are the characteristics, what are the general properties of the halogens, what type of compounds they are going to form. All this information will become easy and study will become easy when we will able to group the and classify the elements. That is the reason classification is done. A question was asked to the student, what are the advantages of classification? Why the scientists are interested to classify the element? What advantages? It enables chemists to predict properties of elements and their compound based on their position in the periodic table. So if I am able to classify or make a periodic table, which we will giving you, which will be given to you after this chapter, you will be able to see that. This will help us to predict the properties of elements and their compounds, on the basis of their position in the periodic table. If I form a table, then I am saying, oh, left hand side of the periodic table are metals. Right side, I am saying they are non-metals. And when I say metals, you already know what metals means, what type of metals. Then inside you are saying there are certain metals like silver, copper, gold. And you are saying, oh, we know already what metals are. They are good conductors of heat and electricity. The metals have metallic luster. All this information becomes easier when we put them in certain periodic form, in tabular form. It becomes easier to study, understand, and then we can compare and contrast the related properties of one element with one group of element with another group, and then we can apply and use them, application part. And we can apply them in our different uses, whatever use we do for different compounds and substances. What is the history of the periodic table of element? Little information, because we are coming to the point. The earliest attempt to classify the elements resulted in grouping them known as metals. First attempts which were made, they said to form two things. They said there are metals and non-metals. Metals, you say copper is a metal, silver is a metal, gold is a metal, and very less elements were known. So they were saying, okay, put them in two categories. Non-metal, carbon is a non-metal, oxygen, nitrogen, so halogens. So they are saying that we can group the elements into two forms, metals and non-metal. That was the easiest and the first. Second, the earliest attempt to classify element was in 1789, when Lavoisier grouped element based on their properties. Lavoisier in 1789 said, oh, certain things are gases, some are non-metals, some are metals, and like earth. Several other attempts were made to group elements together over coming decades. So scientists were trying to make certain classification groups or based on characteristics or properties. Who first published the classification of element? It goes to Mendeleev. We will be talking about that. Mendeleev's periodic table will come. The first one given in the books is Dobereiner'S Triads. Dobereiner's Law of Triads, what he did, at that time, the number of elements discovered were very small. When elements are arranged in order of increasing atomic masses, groups of three elements or triads were found to have similar chemical properties. Dobereiner made Law of Triads. This is called Law of Triads. Triad means three elements. He grouped three elements and said, okay, their properties are similar. And that was the basis, was atomic mass. He arranged them according to increasing atomic mass. Arrange the elements according to increasing atomic masses. And they, he said, are having similar chemical properties. Similar chemical properties. The atomic, and what he found, the atomic mass of the middle element of the triad being equal to the arithmetic mean of the atomic masses of the two elements. What he is saying? He is forming triads. Triad means there will be three elements. Element A, element B, element C. Three elements. And what he said, what is the basis? Basis is atomic mass. The atomic mass of B will be equal to, what is saying, arithmetic mean of atomic masses of the other two. That means atomic mass, if atomic mass of A is Ma, if atomic mass of C is Mc, then atomic mass of B is almost, he is saying, is almost equal to Ma plus Mc by 2. Arithmetic mean of these two. That was the basis of the Dobereiner's Law of Triads. The atomic mass of A plus atomic mass of C, arithmetic mean means divided by 2, is almost equal to atomic mass of element B, and A, B and C have similar chemical properties. So in 1829, German chemist John Dobereiner placed various groups of three elements into groups called triads. One such triad is lithium, sodium, and potassium. Lithium, sodium, and potassium. This is one of the triad. Three elements mean triads. So they have similar chemical properties. You know, they are metals. Lithium is a metal, sodium is a metal, potassium is a metal. And the mass of the sodium will be arithmetic, almost arithmetic mean of lithium and potassium. Lithium and potassium. That is the idea of the Dobereiner. Let us see what we are saying. Examples. Note down because questions can be put like this. Examples. What examples we are getting? Sodium, atomic mass of sodium is, I can take atomic mass of sodium as 3. That is the atomic mass of sodium. Atomic mass of potassium, 39 if I take. Then what is the mean of that? Arithmetic mean. 23 plus 39 by 2. How much it will be? Can you calculate how much value it will come? I think let us put it, this will not come, then what I can take? You can take
31.
31, then it is not. Take lithium. Let me put in this step form: lithium, sodium, and potassium. Okay? Take the atomic mass of lithium. How much? 7. This will be taken as 7, 23. Okay, take it 39. And what is the potassium? 39. Then take 39 plus 7 by 2. How much it is coming?
23.
23. 46 by 2, 23. And that is the atomic mass of sodium. Okay?
Yes, sir.
So, if I have what the law of triad is now clear, lithium, sodium, and potassium were arranged. Lithium, sodium, and potassium are arranged in the triad form. Then we find that lithium, sodium, potassium, they have similar chemical properties, and the mass of sodium, sodium symbol is Na, is the arithmetic mean, is the mean of lithium, mass of lithium plus mass of potassium divided by 2, which is coming to be 23. Let us see other one. You have calcium, strontium, and barium. Okay? If this triad is putting this triad in this form: lithium, sodium, and next one, what do you have? Calcium, strontium, and barium. Let us see. Calcium, strontium, barium, they have similar, but they have similar chemical properties. Dobereiner is saying that. And then add the mass of calcium and barium, how much it is coming? Mass of calcium is how much? 40. And what is the mass of barium? 137 approximately. You take, divide by 2. How much you are getting? Find out what is the value. 137 plus 47 by 2. How much? About 88. Huh?
Yes, sir.
So that mass is almost equal to mass of the strontium. So the arithmetic
Yes, sir.
mean, what he said, in the triads, the arithmetic mean of atomic masses of 2 elements is the middle element. This is the middle element here. And the properties are similar. So his basis was based on atomic mass. The basis of Dobereiner is atomic mass, law of triad. The arithmetic mean of the 2 gives the third mass. The question which was asked to the students: what is Dobereiner triad, and explain. Dobereiner triads are defined any several sets of 3 chemically same elements. The atomic weight of one is nearly equal to the mean atomic weights of the other 2 elements. Is that what we are saying? Chemically, they are similar.
Yes, sir.
Triad means 3 elements. There are 3 elements. That is why we say triad. Chemically Similar, you are saying same means similar properties. And atomic weight of one is the arithmetic mean of other two elements. This is the basis of the Dobereiner. Now the question is calcium, strontium, barium and triad. What is your answer? Did they form a triad? Did the atomic mass of one of the three
Yes, sir.
they form? Yes. You have just seen this calcium, strontium, barium. The atomic mass of calcium plus barium divided by 2 gives the atomic mass of strontium. Yes, they satisfy the conditions which I have written. These are the three conditions. He observed strontium had similar chemical properties to calcium and barium, and that due to atomic weight of strontium is average atomic weight of calcium and barium. Then it is the law. It obeys the law of triad. Questions will be put in the exam whether it obeys the law of triad or not. Every time we discuss a topic, we give you questions. Questions. What type of questions? The answer then, yes. They obey the Dobereiner law. Another question was asked to the student in the exam. Question. These are question answers now based on Dobereiner law of triads. Is copper, silver, and gold a triad? What is your answer, student? You have 1 to 2 minutes to answer the question. The atomic weight of copper is given, atomic weight of silver is given, atomic weight of gold is given. Question is do they obey the Dobereiner law of triad? Do they form Dobereiner law of triad? Yes or no? Question. You have 1 to 2 minutes. What is your answer coming?
So they are not following rule, the triad rule.
If I say the atomic mass of the middle element, you have copper, you have silver and gold. If I add this, supposing I take this 63 and 197, what is it coming? 63 plus 197 by 2 is 130. But silver is 108. So this is not correct. So the atomic mass of the middle element is not obeying the Dobereiner triad rule. Therefore, the answer is no. Answer is no, because the mass of silver is not the arithmetic mean of copper and gold. Such questions will be there in paper. Now here you are given some groups of 3 elements which were given by Dobereiner. Dobereiner gave only few sets, only few triads. So at that time, not many elements were known. These elements are arranged downwards. They are arranged in increasing order of atomic masses. Can you find out which of these groups form Dobereiner triads? Can you tell me? You have group A, B, and C. Question. You have group A elements. Do they form Dobereiner triads? What is your answer? Which group form Dobereiner triads out of these A, B, and C?
Just 1 second.
Okay, do it.
The group B and C.
Acha. This is not forming A?
No, sir.
75 plus 14. 75 plus 14. If I take group
89 upon 2. That is 44.5.
Divided by 2. How much it is coming?
Sir, 89 upon 2, 44.5.
44.5. And what is phosphorus? 31. Not matching. No, not correct. This is not forming. What about B? B is forming. We already discussed calcium, strontium.
Yes, sir.
Yes. What about this?
So C also forms.
C. Let me see. Group C, chlorine 35.5. 35.5 plus 126.9 divided by 2. How much it is coming?
So we will add 35 and 127 now.
Okay. Yes. No problem. You can do approximately. Almost. Matlab. What is the answer coming? Coming around 80?
Sir, yes, sir. 157 upon 2. Yes, sir.
It's coming around 80. So that obeys. Okay. This forms.
Yes, sir.
So our answer, if such question will be given in the paper, our answer, one of the question will be given. That's what the important question. Our answer, group B and C, group B and C form Dobereiner's triad. Law of triads. So I hope there is no doubt about this one. But then what was the reason? He will ask that this was rejected. This model which was given by Dobereiner, that was not found to be very useful. Why? He could identify only 3 triads. See, from the elements known at that time. At that time, whatever elements were known, he could only form 3 triads. Therefore, this was of no good. Okay? This is a limitation. And that is why this model was rejected. Something is applicable only for 1 or 2 or 3 groups, only 3 triads, then it is of no use. Okay. Now here is what we know about John Wolfgang Dobereiner. Dobereiner studied as a pharmacist in Germany. He was in Germany, then studied chemistry at Strasbourg. Eventually, he became a professor of chemistry and pharmacy at University of Jena. Made the first observation on platinum as a catalyst and discovered similar triads of element which led to development of periodic table. So these are the 3 triads which were given by him: lithium, sodium, potassium, calcium, strontium, barium, chloride, bromide. 3 triads. Only 3, therefore, this is not useful. After this came the Newlands Law of Octaves. They will ask you, what is Newlands Law of Octaves? The law of octaves states that every 8th element has similar properties when elements are arranged in increasing order of their atomic mass. So here again, atomic mass is used in this also. What he used, as we said, in this atomic weight, he is also using atomic mass. This next one is also using atomic mass. What he did, he arranged the elements according to increasing atomic masses. Newland, what he did, he arranged elements according to increasing atomic masses. And has similar properties. Every 8th element, he found every 8th element. Every 8th element was found to have similar properties. arrange when then known elements in the order of increasing atomic masses. He started the element having lowest atomic mass, hydrogen, ended up with thorium, which was 56. He found every eighth element had properties similar to that first. He compared this to octaves found in music. In music, music में octaves का पता है आपको, octaves का use हुआ.
Yes,
Therefore,
sir.
he called law of octaves. Octaves, the properties of lithium and sodium were found to be same. Sodium is the eighth element after lithium. When he arranged them in increasing order of the atomic masses, eighth element after lithium was sodium in the atomic mass. They were having similar properties. Similarly, beryllium, magnesium resemble each other. So let us see what is the part of the Newlands law of octaves, Newlands periodic classification. You can see there are certain notes of music which are used sa, re, ga, ma, pa, na, da, ni. What are these notes of the music? So he used it octaves. Hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. So if I start from lithium, 1, 2, 3, 4, 5, 6. This is 7 and eighth element. This is the eighth element. So again, if you start 1, 2, 3, 4, 5, 6, 7, this is the eighth element. Now these elements, he said, are similar properties. They have eighth element. Lithium and sodium, this is the eighth element. In this table, they have similar properties. Beryllium and magnesium. Magnesium is the eighth element in the periodic classification, similar property. Then it says boron and aluminium. This is eighth element, similar properties. Carbon, silicon, nitrogen, like this. This was arranged by Newland based on the notes of the music. So beryllium, magnesium, boron, and aluminium. This is the eighth element. Carbon and silicon, all this eighth element. What are the limitations of Newlands law of octaves? Question will be like this. What are the problems? What are the drawbacks of the octaves? It was found law of octaves was applicable only up to calcium. First, it was applicable. Which one? Law of octaves. Applicable only up to calcium. And after calcium, every eighth element did not possess properties similar to that. Then after calcium, it was not having same properties. Only up to calcium. It was assumed by Newland only 56 elements existed in nature and no more elements were discovered. At that time, only 56 elements were known. And he said, okay, that is the end. No more elements will be known, but that is not correct. But later, what happened? More elements were discovered. And properties did not fit. And properties did not fit. Did not fit, student, in the law of octaves. In order to fit elements in table, Newland adjusted two elements in the same plot, but also put some unlike elements under the same plot. There were some unlike elements which do not have similar properties. Cobalt and nickel are in the same slot as these are placed in the column of fluorine, chlorine, and bromine. You see, chlorine, fluorine, and bromine. And in this, they have also put cobalt and nickel. Cobalt and nickel. But their properties are not resembling with them. Iron these have different properties. Cobalt and nickel have different properties than chlorine, bromine, fluorine. They are put in the same. Where is that? See, carbon, nitrogen, oxygen, sulfur, and here also these properties are different. Iron does not have similar properties. Here he has put fluorine, chlorine, and these two do not have same properties. They have very different properties. This is cobalt, this is nickel, as compared to fluorine, chlorine, and bromine. As compared to fluorine, chlorine, bromine. Here also there are some, you can see discrepancies, and these boron and aluminum, this does not have the similar properties, and these properties are different from boron and aluminum. Oxygen, sulfur, then you have iron. These properties are different from oxygen and sulfur. So as more elements were discovered and there were difficulties, therefore what is important, further the discovery of noble gases, the law of octaves become irrelevant. Then what happened? Noble gases were discovered. Discovery of noble gases. And then this law became irrelevant. This law also became invalid. It was no good. This becomes irrelevant, means invalid. So this was also rejected. These are the limitations of the Newlands Law of Octaves. A question was asked to the students. Question, what is the question in the paper? What are the merits and demerits of Newlands Law of Octaves? Such questions will be given in such cases. Merits and demerits. Dobereiner's merits and demerits, for example. You know what are the triads? Only 3 triads were known. And now we are talking of law of octaves. Atomic mass is the basis. Atomic weights he arranged, and every 8th element has similar property. But as more elements were discovered, it was not true. Even in the table which he has given, there are problems and discrepancies. The classification worked well for merits, lighter elements up to calcium. This classification gave us a relation between properties of elements and their atomic masses. These relationships are showing that there is some relationship between the properties and atomic mass of the elements. It was shown by this classification for the first time there exists a periodicity in the properties of the element. So at that time it became important that some periodicity exists in the properties. Periodicity means repetition of the properties of the elements. Periodic means what? Which repeats. Properties of the elements repeat after you arrange the elements in terms of their increasing atomic masses. What are the demerits? The classification failed when heavier elements beyond calcium were arranged according to new. So when more elements were discovered after calcium, it failed. At the time of this law, noble gases were unknown. When noble gases were discovered, neon between fluorine and argon between it becomes 9th element and not the 8th element, which has similar properties. Therefore, with the discovery of noble gases, again the whole Newlands Law of Octaves became invalid, irrelevant, and therefore this was also not a good periodic classification of the elements. So I hope by now we have given 2 important periodic classification. We have given answer what is periodic classification is required, and some history, and Dobereiner's merits and demerits, and then merits and demerits of Newlands Law of Octaves. Okay, then we will meet you in the next class further.
सर एक बार मेरे को वो ऑक्टेव वाला फिर से करा देना.
हाँ
सर वो ऑक्टेव वाला फिर से करा देना एक बार.
हाँ सुनो, ऑक्टेव्स में मैं ये कह रहा हूँ इम्पोर्टेंट है. Newlands Law of Octaves arranges elements according to increasing order of atomic masses. What he did, he took elements and arranged them according to increasing atomic masses. And what he found, that 8th element has similar properties. And then he formed a law of octaves. The reason he talked of octaves because they were similar to music notes of the octaves. For example, the properties of lithium and sodium were found to be the same. when he arranged according to increasing atomic mass. Increasing atomic mass. Sodium is the 8th element after lithium. Similarly, beryllium and magnesium resemble in the properties. Now, this is the table. Let me see the table, students. This is the table. You can see hydrogen, lithium. This is a atomic masses are increasing, student. If I have to arrange them, increasing, they are being arranged in the order of increasing atomic masses or weights, whatever you say. Now, if you see what he found when he was arranging in increasing atomic masses, he found the property of sodium is similar to lithium. Lithium and sodium, they have similar chemical properties, similar properties. Then what he said, okay, he arranged lithium below sodium. Okay? And when he found in terms of atomic masses, this came to the 8th element. How? Count it. Start from here. 1, 2, 3, 4, 5, 6, 7th and 8th. This is the increasing atomic masses. Increasing atomic masses. Similarly, what he found? This is the 8th element in terms of increasing atomic masses. Increasing atomic masses. Now, what he found, if I consider beryllium, okay, and increase the atomic mass, what he found that beryllium and magnesium, they are similar. What they found? They have similar properties. By similar properties means what? He will be reacting with some hydrogen, with oxygen and try to form compounds. He will found similar type of compounds, similar type of substances being formed by beryllium and magnesium. So he says, oh, they are very similar in properties. Now, this magnesium is again what element? Count 1, 2, 3, 4, 5, 6, 7, 8. Okay? Again, 8th element from magnesium. So what is he saying? In this table, elements are arranged in increasing atomic weights, and 8th element is similar in behavior, in properties with the element. So that was the basis of Newlands octave. Octave means 8th element. So he compared that with the notes of music which we use, whatever notes we use. Got it?
Yes,
Any
sir.
doubt?
No, sir.
Questions, and we have given you merits and demerits every time, students, because questions will be asked on that. How good this classification is and what are the problems, why it is rejected. Because as more and more elements were discovered, and then they found that this table doesn't work. And we will study in the next lectures what other attempts were made. And finally, the table which we are using now, that is the final table which we are using, the modern periodic table, which is based on atomic number. Okay, then we will meet you in the next class.
Yes, sir. Bye.
Tomorrow we want class or not, students?
Sir, I'll message you.
Okay, bye.